Click the link in the description to download your own copy of this video's problem. Hey guys, Russ here. Welcome back to another fantastic chemistry video. And today we're going to learn about using IUPAC rules to name alkanes. Very, very simple, but fundamental. Okay, so we're going to go through the rules, the steps to follow to name substituted alkanes. No problem. Okay, let's take a look at this first example right here. So now it's an alkane. No double bonds, no triple bonds, no heteroatoms, no oxygen, no nitrogen, no sulfur. So it's an alkane. Okay? So the first rule, find the longest continuous chain of carbons. So that means unbroken. So in other words, there's no oxygen between two carbons. There's no nitrogen between two carbons. It's the longest unbroken chain. So let's count. 1, 2, 3. So right here, there's 3 carbons in a row. Obviously, there's a longer chain than 3. So let's try another way. 1, 2, 3, 4. So going this way, we get 4 carbons in a chain. But I still think we can do better. 1, 2, 3, 4, 5, 6, 7, 8. So this is no doubt our longest chain. Let's maybe circle it in purple just so you can see it. So that's your longest continuous chain of carbons. And it's 8, so that's called an octane. So when we're naming this molecule, it's going to be this, that, the other thing, octane. Okay, so the last thing out of our mouth or on our paper is going to be the word octane. Now, oops, let me just go back and get rid of that circle so I have more room. So now when you're doing this, you're going to have to tell the reader or your faculty member, yours truly or someone else, what substituents are where. In other words, what carbon are the substituents attached to, and what are those substituents? So we have to number the carbons. Now the rule for numbering carbons in a chain is you always start at the end closest to the first substituent. You always start at the end closest to the first substituent. So that's obviously going to be this carbon right here. 1, 2, 3, 4, 5, 6, 7, 8. So this is going to be carbon number 1, number 2, 3, 4, 5, 6, 7, and 8. So carbon 1 is on the right-hand side. That's just how it went in this question. It doesn't have to be on the right. Could have been on the left. So now, this is an octane, no question about it. And on carbon number 2, there is this substituent right here. And that is a CH3, so that's a methyl. And on carbon number 3, there is a methyl. So now, we have to put it all together. When you have the same substituent more than once in a molecule, you have to group them together. Okay? So you would say the following. 2, 3. Now, in naming, in the IUPAC system, numbers are separated with commas. Numbers are separated with commas. So it's 2, 3. Dash. In the system, letters and numbers are separated with dashes. So it's 2, 3 dash. Now there's a dash, so the next thing I should write has to be a letter. So you're going to write dimethyl. You have to write dimethyl because there's 2 of them. So in the system, if there's 2 numbers here, there better be a di right here. If there's 3 numbers here, there should be a tri. If there's 4 numbers out here, tetra. You have to do that. That's part of the system. So 2, 3 dash dimethyl, and then you put the word octane. 2, 3 dash dimethyl octane, and dimethyl octane is all one word. Okay? And that's how that system works. So far, so good. So that's example number 1. Let's look at example number 2. Again, count your carbons. Find the longest continuous chain of carbons. 1, 2, 3, 4, 5, 6. That's a pretty good one, 6. But I think we can do better. 1, 2, 3, 4, 5, 6. So there's 6 again going that way. Still think we can do better. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's a 10 carbon chain right there. But let's be careful. Maybe we can do better. 1, 2, 3, 4, 5, 6, 7, 8, 9. So going this way is only 9. So 10 is the one. 10 is the one. Let's do one more count. 1, 2, 3, 4, 5, 6, 7. So that's too short. So this is indeed a decane. This is a decane. So it's going to be something, 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 decane. So far, so good? No problem. Now we have to number the carbons. You always start numbering from the carbon closest to the first substituent. So 1, 2, 3, 4. Carbon number 4 is where the first substituent starts if we count from the left. 1, 2, 3, 4, 5, 6 if we go from the right. So we have to number from the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this is a decane. At carbon number 4, there is this group here, and that's an ethyl. And on carbon number 5, there is a methyl. Now, we have two different substituents. We have to put them in the name, but you have to put them in the right place. So you're going to say 4-ethyl first, not because of the number 4, but because of the E in ethyl. It's alphabetical at this point. Your substituents always go in alphabetical order based on this letter. Now, even if there was a di or a tri or a tetra, you still base your alphabetical order on the first letter of the name of the substituent. Don't use the prefixes di, tris, and tetras if you have them. This one doesn't have them. But if you were to have them, you don't count those as part of your alphabetical. It's only ever the first letter of the actual name of the substituent that you're considering. So put all this together. 4-ethyl dash 5-methyl decane. Now, let's consider this name. 4 dash, so between letters and numbers, always a dash, ethyl dash 5 dash letter dash number dash letter. Always. Methyl decane. Methyl decane is all one word. And that's how you would name example 2. All right, guys, now if you found this video helpful, please go ahead and slap that like button. Consider subscribing to my YouTube channel. It really does help out YouTube creators when you subscribe to our material. And if you would, please leave a comment below. Tell me how I can help you out in your organic chemistry class. Maybe I can take a problem that you're having, make a video just for you and for anyone else who may be struggling with the same topic. And with that, you guys, I want to wish you all good luck and good chemistry. We'll see you soon. Email drbetts@protonmail.com if you would like a copy of every problem in this series.